All right, let's talk about Java. We're going to break down the one simple but totally brilliant promise that made Java one of the most powerful and reliable programming languages on the planet. I mean, this thing is the engine behind so much of the tech you use every single day. Here it is, this one phrase: write once, run anywhere. Now, you gotta understand, this isn't just some catchy marketing slogan. This is the famous promise that sits right at the very heart of Java's design. It's the whole reason for its incredible, long-lasting success. I mean, seriously, stop and think about that for a second. How on earth can one piece of code, written on just one computer, work perfectly on a Windows PC, and then on a Mac laptop, and on some huge Linux server, and even on the Android phone that's right there in your pocket? How does that work? Well, to really get that magic, we have to rewind a bit. We need to go back to its origins and look at the core problem it was so brilliantly designed to solve from the very beginning. So back in 1995, a guy named James Gosling and his team at Sun Microsystems created Java. And they built it from the ground up to be a high-level, object-oriented language that was not tied to any single type of computer. That was a completely revolutionary idea at the time. So, and now for the good part. Let's see how this actually works under the hood. We're about to pull back the curtain and reveal the secret sauce that makes that run anywhere promise a reality. It's this brilliant three-step process. Think of it like a master recipe. Okay, so in step 1, the developer writes the recipe in plain English. That's your source code. Then, in step 2, that recipe gets compiled, but not into a specific meal. Instead, it becomes a set of universal cooking instructions. And finally, in step 3, a local chef in a kitchen takes over. And this middle step, this is the absolute key: bytecode. In our analogy, this is that set of universal cooking instructions. See, it isn't written for a gas stove or a microwave. It's a completely neutral language that any kitchen can use, just as long as there's a chef who knows how to read it. And that brings us to the Java Virtual Machine, or JVM. The JVM is the master chef in every single kitchen. It lives on your specific device, and its job is to read those universal instructions, the bytecode, and translate them perfectly for its local equipment. It doesn't matter if it's a Windows PC, a Mac, or an Android phone. That's the secret. Pretty clever, right? Okay, so now that we know how it all works, let's take a look at what a Java program is actually made of. What are the fundamental building blocks? Every single Java program is constructed from just a few core components. You've got classes and objects, which are basically the blueprints for your code. Then you have variables to hold on to data and methods to actually perform actions. And then you use packages and libraries to keep things organized and use tools that other people have already built. Let's start with the most important one. Let's really focus on this because it's the most fundamental concept: classes and objects. Think of it like this. A class is the architectural blueprint for a house. It details everything: how many rooms, where the windows go, all of it. An object is the actual physical house you build from that exact blueprint. And the cool part is, you can build as many houses or objects as you want from that one single class. And you can see these ideas in action even in the simplest Hello World program. You can see right here, the program defines a class called Hello World, and inside of it, there's a method named main, and that method's only job is to perform one action: print a message to the screen. Super simple, but it shows you exactly how these core pieces fit together. But hey, a language is nothing without the right tools to actually use it, right? So let's take a quick look at the essential toolkit that Java developers work with every day. Now, this is really interesting because you can see the clear difference between these two kits. The JDK, the Java Development Kit, that's for the creators. Think of it like the entire car factory. It's got all the tools to design, build, and test a brand new car. But the JRE, the Java Runtime Environment, that's for the users. It's just the car itself. You don't need the whole factory just to drive the car, right? So when you boil it all down, there are 3 key parts to remember. You've got the JVM, which translates the code. You have the JRE, which lets you run the programs. And you have the JDK, which lets you build them. Those 3 pieces together make up the entire Java platform. So all of this leads to the big question. This language is almost 30 years old. In the tech world, that's basically ancient. So why? Why is it still one of the most dominant forces in the entire industry today? Well, for starters, how about this? The operating system on billions, and I mean billions, of smartphones all over the world is built on Java. Its stability and its performance make it the absolute cornerstone of the mobile world. It's also the reliable, super secure workhorse behind massive, large-scale enterprise applications. We're talking about global banking systems, stock trading platforms, and huge corporate software that just cannot fail. And don't think it's been left in the past, not at all. Java's raw power and its mature ecosystem have made it a major player in all the hot new fields. It's driving the engines behind big data processing and a whole lot of artificial intelligence applications.
And finally, for anyone just learning to code, Java is an amazing place to start. It gives you this powerful, rock-solid foundation. Its structured nature teaches you these core programming concepts that just make it so much easier to pick up countless other languages and frameworks later on.
So, there you have it. That's the fundamental map to one of the most important and enduring landscapes in all of technology. Java's story really is one of incredibly smart design and amazing adaptability. So now that you know the foundation, the only question left is, what are you going to build with it?